Hello and welcome back at this stage. I'm very pleased to welcome now our highly esteemed iSAQB member, Eberhard Wolff. Eberhard has over 20 years of experience as an architect and consultant, and he is head of architecture at SwagLab. And he has written many articles and books, for example, mostly about microservices and continuous delivery. Eberhard, it's nice to have you here. Let's start with your session.
Yeah, thank you so much. Thanks for the invitation, for the introduction. I'm really happy to be here. So I am going to talk about legacy systems and whether that's really a problem. So first of all, let me say that legacy is a challenge. So it's not that that I want to say that it's all trivial concerning legacy, but really it is a challenge. However, at the same time, I would argue that if you're working on legacy systems, I would like to congratulate you on doing so. And the reason why I think it's great to work on legacy software is because legacy software does have business value. Otherwise, you wouldn't be working on it. So it is old software. And if that old software is not valuable, then the organization would just get rid of it. So the job you're doing is important, and it's also, I would say, an interesting challenge. That's one of the reasons why I really enjoy working with legacy systems, because it's not trivial at all. So there is a lot of stuff that you can learn and that you can do there. So that is why I like the challenge. Let me also add, for the non-native speakers, legacy has a positive connotation, at least outside IT. So here in Germany, I met a person at one point who said, well, we should really have a different name for legacy software because it's so negative. We should call it heritage or something like that. And I had to point out to him, and I reassured myself, talking to some native speakers, that legacy is actually something that is positive. It's just that in IT, things are so twisted that it became negative. So why are there advantages of working with legacy systems? Well, let me first of all ask the question, what is software development actually all about? And, you know, this seems to be a trivial question because it seems to be about code. Obviously, right? We are developing software, so this is all about code. But really, if you look at it, I'm not too sure. So here is a screenshot from the Scala compiler and the contributors to the Scala compiler. And this person over here, he wrote about 425,000 lines of code, and he deleted 451,000 lines of code. And the next person also essentially deleted about 15,000 lines of code. So they didn't produce any code, they deleted code. Still, what they are doing is valuable. It's actually very valuable because there are more features now. The whole thing is simpler. So therefore, I think they did do quite a significant contribution to the compiler. But it's obviously not about just producing code. And I did write an article in German, I'm afraid, about AI and software development, which doesn't seem to have a relation to legacy software, but really this blog article talks about how software development is not about producing code, it's about other things. It's about understanding what code should be produced. And that's the major challenge. So therefore, the problem that we have is different. It's not just code. And I would argue that software development is actually about learning. So we learn how to do things better. That is why we go to conferences. That is why we listen to talks, why we read blog articles. We learn more about the domain, how it should really be implemented, what the logic is really like. We learn more about the business case. So we learn about what customers actually want, which means that we might want to change our code and our domain model. We learn more about architecture, how to do architecture. not just for the specific problem, but also in general. So the way that I think about architecture has obviously shifted through the years. So that is something that changed. We learn more about technologies, different technologies, and so on. And the advantage for legacy now is that we actually know stuff. We know quite a few things. And the reason why we do that is because one approach to solving the domain problem has already been implemented. So therefore, we know the domain, we know which problem should be solved. We know the business case, we know how the software is valuable and what problems for customers it solves. We know one architecture that works. At least there is some working software that has that architecture. We know about some technologies that can be used to solve the problem. And in particular, we know the domain experts. If we have a running system, we know all the stakeholders, and the stakeholders are the ones include the domain experts. And we know that because we talk to them frequently, and we also know the users. In a greenfield application, that is not too clear. So who is going to use that application? If we have something that is out in the internet, we don't know at all who's going to use that application. Maybe it's nobody. If we have a legacy software, we do know who uses it, and we even can figure out who is a power user and using some more or less features. So what else is there? So we also know the weaknesses of the system at hand, and if it might, so there has to be some reason why we want to improve the legacy system, why we think that the system doesn't fit what we need to do with it at the moment. And I would argue that one of the reasons why we need to change the system is outdated technology. So we might have a technology that is not really supported anymore, and that might be a reason why we want to change the system. Also, the system might be hard to change. So it is possible that the system has a bad architecture, is badly structured, so therefore it's hard to change. However, software that is hard to change is not really a problem unless you actually do need to change it. So the real problem is that we have new requirements, and those requirements are hard to implement. So therefore, the software that is hard to change, that is a problem because we do have new requirements. So the real problem is new requirements. If it wasn't for new requirements, how to change software would be acceptable. So let's dive deeper into those specific topics. So we have the outdated technology. And I have to admit that I'm not really sure whether this is really a problem in itself. So software development is costly and high risk. If we have a new system that should be created, it takes a lot of effort to create that system, and it's quite risky because we all know that such projects can, well, eventually fail. So I wouldn't be surprised if sticking to an old technology would be less risky and cheaper because you don't need to do a lot of development. And in particular, if you, in those cases where you say, okay, there is some mainframe system and that mainframe system is really expensive and we need to get rid of it, I would like to see a calculation that says, okay, this is the effort that we are going to invest in building the new system. This is the price that we are paying for the legacy system, for the operations of the legacy system. And there is a business case that says, okay, we need to migrate away from it. And I have to admit that I have yet to see such a calculation. I'm pretty sure there are some, but I haven't seen them for myself. So what are the alternatives? An alternative would be to educate the developers in the old system. That might take some time. So even if you have a COBOL developer, I wouldn't be surprised if the COBOL developer takes a year or so to learn the old system, even though it's written in COBOL. And at the end of the day, that shouldn't be too surprising because, you know, just because I know Java doesn't mean at all that all the other systems that are written in Java, that I understand them. Each system is different, and that is also the case for COBOL or any other language. But still, even if you invest a year to get people up to speed with the system, or maybe if you get some people from the school and have them as apprentice and teach them how to program, that might still be less of an investment compared to building the system anew. However, there are problems. So if you don't get any security updates anymore for the technology that you're using, then maybe you need to migrate away. So if you're still using Windows XP, for example, that is probably such a security risk that you want to get away from it. And therefore, at one point, you probably need to migrate. So here is one thing that, one kind of discussion that I had more than once. So the question is, why don't you use a cross-compiler emulator or some kind of automated translation to take the old system and translate it into a new system? So there are COBOL cross-compilers, for example, that would allow you to run COBOL code on the JVM. So why don't you do that? This is low risk because it's just a technical means of getting the software to a new platform. And it's also cost efficient because you just need to buy that software. And that's probably cheaper than, getting a team of developers to build the system. And the response that I got more than once is, well, this doesn't make any sense at all because the software has to be changeable. And if that's the case, that's fine. And, that's a good point. And it's great that we have that point on the table now. But it means that it's not just about the outdated technology. And my understanding is that if you migrate away from an old system, usually the problem is not just the outdated technology. It's also something else. Somehow the software has to be changeable, which means there are new requirements. And there is also another problem here. So let's imagine that we have some software. So here is the graphic user interface or the API. Then we have the old complex architecture below that. And now what we do is we have the very same UI, the very same API. So to users, nothing changes at all, but we have a clean architecture. Why would a user or a business expert support this migration? At the end of the day, for them, nothing changes at all. There might be a small change because now software is easier maintainable and therefore it's more cost efficient to do changes to the software. But really, there is no new business case or nothing at all. And this is a problem because you do need the support of the business experts and of the users to work on this migration because they know what the business logic should be like, what the business case is like. And if you try to do that project and you need to work against them, that's going to be a risk, and it's going to be it's going to be hard to do the job because they should be your allies. So you do need also their political support, because if they fight the system you're building, they are the ones who are going to use the system, or well, who are not going to use the system then, and that makes your project really, really hard. So I would argue that the hard to change is only valuable or is only a problem if you have new requirements. And a project that just says, okay, we have an outdated technology, that's usually not the only driver. In my opinion, most of the projects say, okay, so the technology is outdated, and really we also need to have the system changeable. So the real problem becomes the support for new requirements. And therefore, the recommendation that I would give is do provide business value, even if you're in a technology migration, because that makes your life just so much easier. And one of the first large projects that I've been part of did try to just migrate a system from platform A to platform B without changing any of the business logic. And that was a rather unpleasant project, because at the end of the day, the business experts didn't really support the project and weren't really interested in supporting the project. And that is a disadvantage. If you have a legacy system, as I said, there are some advantages. So you do know quite a few things. So one of the things that you do know is you know the business case and the domain experts. And that is because there is already a system, and that system is also useful. It is something that people are using. So we just need to optimize the system, and I put that in quotes because obviously that's a tough challenge and might mean that you need to redo the whole system. But the existing system can give us some feedback, some freedom to do so successfully, because there is already a system that solves the business problem. So that means that there is, well, if the new system isn't done in time, there is still a fallback, which might not be the best option ever, but there is at least still some fallback. But something has to change, and that is what is usually called a migration from the old legacy system to something new. And one of the things that I think is interesting is, so how long will the migration take? And one of the questions that you can ask to get an estimate about that is to ask the question, how long did the development of the original system take? So if the original system took 10 years to develop, and now you say, okay, we're going to it's just going to take a year to replace the system, it means that you're 10 times quicker than the original development. And that leads to the question, why? Why do you think you're going to be so much faster? I would just let people estimate the time. And that is actually something that I did in at least one project where I had people just estimate the time in months that it would take to replace the system. And I did that with Fibonacci numbers. That's a set of numbers where the sum of two consecutive numbers is taken to calculate the next number. And the result that they gave were 89 months, which is about 7 years. And they pretty much all voted for 89 months, which means that this is the common understanding that it's going to take 89 months. And that is an interesting result. First of all, if they didn't agree, that could bring an interesting discussion why they don't agree. That's one of the things that you can take away from estimates, that they can lead to some interesting discussions. But in this case, we didn't need to have that discussion because everyone basically agreed. And I think you cannot possibly run such a project that takes 7 years and provide business value only at the very end, because it means that you wouldn't provide any value whatsoever for 7 years. And that's a very, very long time. No company these days thinks in these kinds of timeframes. So you need to somehow do the migration stepwise, and you need to provide some business value while the project runs. So that means you shouldn't do the big bang, the great fireworks, the great explosion on the horizon, but you should do a stepwise migration. That is what you should be aiming for, in my opinion. And the reason is because it's less risky. So you do each step, you put each step in production, you get some feedback, and that stuff that is in production, well, it is in production. So you have at least something that is running there. You can provide value while you're migrating. With each step, you can provide more value. Big Bang might be an option for rather small and simple systems, but not for the large systems. And those are the ones where, consultants like myself are usually asked for some advice. There is another reason why I think you should work stepwise, because a complex system that works is invariably found to have evolved from a simple system that worked. So that's a fundamental hypothesis in systems theory. And if you have that complex system that is running there, the legacy system, and you're building the new system as a complete replacement, that's not going to work. That's what this sentence basically says, right? And therefore, you have to work stepwise. So here is another advantage. The advantage is that you do have one implementation of the business logic. And that leads to the question, should you just implement the same logic anew? the very, very same logic. I would rather not do that because it means that you're going to have a rather slow development because you need to figure out what the code actually says and what it's meant to do. And then you need to program that in you, and you need to be really perfect about that. It's also frustrating. That's not a pleasant thing to do as a developer. This is often something that is done if IT is the driver. So it might be a scenario like, okay, so we still have that mainframe here. We want to get rid of it. That's an IT problem. So we just build the same software on a new platform that is not a mainframe. And then you end up with a very complex system because you're basically tied to what already is there in the legacy system. And basically you're building a new legacy system that is, again, hard to change and hard to work with. And here is a slide that I've already shown. This is basically what you're doing, right? You're building the very same system to users. It's the very same system, so they don't have any reason to support what you're doing, and that again is a problem. So I would argue that you shouldn't do that. Even if you just want to get rid of the original technology, you should do more than that and have a different approach. And there is an advantage there. And the advantage is that you know the business case, the domain experts, and the users. Because the legacy system is in production, so you do know who is using the system, who are the stakeholders, and you also know what the business case is. So therefore, you can now explore the domain. And you can try to figure out whether there is any new and useful business logic that you want to implement. So what are things that users like? What is the value of the system? How can you improve the value? So one idea that you might want to implement is to talk to the users of the system to figure out what they are lacking right now. And here is an example from my own experience from a consulting gig that I did. So I was asked to do a review for a migration to microservices. As Mirko said, I have actually written a few books about microservices, so that seems to be something that is that I have some understanding about. And at the very end of that, and the review basically said it was actually quite positive. It said, yeah, you're basically doing everything right. But then at the very end, I talked to the manager who was managing the whole project, and I asked that manager, okay, so what is the value to the customer of your company, to the user of that system? What is the value of the migration? And I actually asked that question several times because they wouldn't come up with an answer. And the answer would have been, well, there's no value. So what they did is they came up with a new strategy to implement new features. In that specific case, it allowed people to have a much broader variety of products to choose from and to buy. And that's a valuable feature, as you can probably tell. And the result was that this project now became much more valuable because there is a clear business value. It's not just that it solves an IT problem because there's that old software that it will be replaced by new software, but there are actually new features that are valuable. The other example, I could give more examples from my own history, but I want to give a different example. So again, it's a stepwise migration to microservices by the book. And the original plan was to provide no business value whatsoever, which means that it was frustrating, as I said, because it's a very mechanical task that you're looking at. But the people figured out that the users were struggling with the reporting feature of the system. And that is something that they figured out by, actually talking to that users. And therefore, they implemented new reporting, which they would otherwise not have done or would have done very, very late. And that led to high motivation for the team because they felt like they are actually helpful, and also high motivation to the business experts. And I did a stream about the Strangler fig pattern in German. Sorry about that, but if you go to that URL, there is a link to the paper that talks about the Strangler fig pattern. And the Strangler fig pattern, that paper describes the the case that I've just been talking about. So there is a clear indication that just doing a technical migration from A to B, that is not what provides a lot of value. And I think this is related to domain-driven design, because domain-driven design basically says that you should have you should let the domain drive the design. So therefore, you should let the domain drive the migration, and that leads to the question: so where's the business value? And if you do provide business value, it leads to more motivation and more support by business experts and users. And questions that you could ask is: so why are we even migrating the system? What's the reason? And another question that I think is even better is: why are we migrating the system now? Why not in a year? Why not a year ago? Because that means there has to be some concrete reason why we are doing it at this specific point in time, and that could lead to some understanding about what we are actually trying to achieve in terms of business value and so on. And you could go a step further and argue that migrating a system might actually be the result or the effect of a business strategy shift, which you might need to understand fully. And even though I do believe, as I said, that the domain should drive the design and also the migration, I do have a problem here because I'm an architecture consultant, so I wrote books about microservices and other stuff. So you can easily ask me for my opinion about architecture, but I'm not too sure whether you would ask me for my opinion concerning some business strategy. My colleagues, I'm working at iSAQB, and we do have quite a few colleagues that are specialized in other things, so they might be the ones who could ask these kinds of questions. And there is Nick Tune is actually one of the people who considers a very strategic approach to these kinds of migration. For example, he has a business model canvas to capture the changes in the business model, and those, he says, are the drivers to the migration. You need to understand them to really do the migration properly. I did an episode about that in my stream not too long ago. So that is something where you can find more information. Also, again, the link to the paper, which is in English. The stream is in German. And also there is the architecture modernization book that he is currently working on, which you might want to consider. So I would argue that a legacy migration should not create new legacy, but something different. And I would like to go back to that Strangler-Fick pattern. And that's interesting because oftentimes I hear the term strangler pattern, but it's really Strangler-Fick. And that's a plant that grows somewhere on a tree. So there is a picture here, and you can see that the plant here, the Strangler-Fick, has grown around something that is not there anymore. And the Strangler-Fick would start growing somewhere here, and it grows upwards for light and downward and takes energy from the tree. And the intent of the Strangler-Fick is not to kill the tree, but to, well, just grow. And that is something that I think we can also do for migrating systems. So we start the migration somewhere, not at the roots or at the very top, but somewhere where it is valuable. We take stuff from the original system, so we can have event capture, where we take events that happen in the system and bring it to the new system. We can have something like asset capture, where we take specific data and the new system handles these kinds of customers or products or whatever they are. And then we grow, and the intent is not to kill the legacy application, but to provide value and grow in places where it's valuable. And I think that's the better approach, as opposed to migrating everything for technical reasons and going forward in a technical way. There is another advantage, which is we know the existing architecture. As I said, software development is about learning, and one of the questions that I would like to ask is, so does the migration actually improve the architecture? So let's start off with a clean fresh start. And one of the ways that we can build such a clean architecture is by structuring or clustering functionality. So here's some functionality for an e-commerce system. And we would take invoicing, for example, and we now say, okay, there is a module that does the invoice, which generates a PDF based on the data of the order. And so it's just a black box where the order is put in and then the PDF is generated. And we have the calculation of the VAT. And in the invoice, the VAT is given. So we cluster those 2 points together. Now, we could argue that this doesn't make a lot of sense because really VAT is quite different from the invoicing, and then we would separate it. That's not the point. The point is that we are focusing on functionality. So we are not talking about clustering stuff that changes together or encapsulating stuff. It's just taking functionality and clustering functionality. And with tracking, so tracking answers the question, where is my delivery? Where is my packet? And I would argue that this has pretty much nothing to do with invoicing. So therefore, it should really be a separate module or bounded context. Shopping cart, same thing. When we do the tracking, when we track the order, and when we have the invoice, the shopping cart is actually gone. It morphed into an order. Delivery, the algorithm that figures out how to get stuff to the customer, might be something that belongs to tracking. And then we have accept order, which takes the shopping cart and actually makes it an order. And we now have those 3 modules. And as I said, though the main point here is that we try to structure the system by functionalities that belong together. How we do that in detail is a different question. And we end up with relatively small models. And also if we have a request, so if we have a request, give me the invoice, well, it's going to go to the invoice module. If we have a request that is about shipping stuff, well, it's going to go to the shipping module. So chances are that each request is local to one bounded context. And also if we have some changes, that's also going to be local to one module or bounded context. And that's not a coincidence, that's by design, because we designed our system in a way to make sure that each functionality is in one module. So if we change functionalities, then chances are that just one module it needs to be changed. And if we use one functionality, chances are that just one module will be handling that request. If we have this kind of model, then each of them will include a product. So for invoicing, we will have a product, and what we are interested in is the price. For shipping, we will be interested in the size and weight. For the order process, maybe in the description. And we also have a customer. So for invoicing, we are going to be interested in the billing address. For the shipping, we are going to be interested in the shipping address, and for the order process, maybe in recommendations. And let me point out that actually the customers that we talk about are different. So if I order something that should be delivered to my address in Kaiserslautern, but it is the invoice should go to SWAQLab GmbH in Hamburg, then those are actually 2 different customers. The customer in terms of invoicing is SWAQLab GmbH in Hamburg. The customer in terms of shipping is myself, located in Kaiserslautern. And if I move to a different city, I really do hope that the address of SWAQLab doesn't change. So it's really 2 different customers. And that is one of the points here. Now, this is a clean architecture that we would implement if we had a greenfield project, but we are talking about a legacy project, right? So my advice would be to have an approach where we take a requirement and then try to migrate towards such an architecture. So sort of piggybacking the migration task on the requirement that needs to be implemented. And if we have an existing system like this, where we have the invoicing and order process, and shipping, and we have a product information system and a customer information system. That's a different architecture. In particular, down here, we have a system that knows everything about the product, and we have another system that knows everything about the customer. But we just discussed that the customer is actually different depending on the module that you are talking about. And now we want to build something like the reporting, which is a completely new bounded context. That's what I stole from that case study that I just discussed and the order process. Well, if we do that, I would argue that we should have a replica of some data in those bounded contexts. So for the reporting, we might have some customer data that we replicate here. The reason why I would advise to replicate the data is because then new information that is specific to reporting is in here and not here. So there is more independence. If we have additional information that we only need in reporting, we can implement it here and not in the centralized system. The other thing that I want to point out here is that we won't get rid of those systems for quite some time, because chances are that every system is interested in the customer information system or in the product information system. So getting rid of them is actually going to take quite some time, even though the architecture that we just discussed said that this is not a good idea to have such centralized models, but we have to live with that. Which leads to the question, okay, is this architecture better or worse than the one that we had before? Well, reporting is a new additional part. It has some dependencies on legacy, so we actually have more dependencies on legacy, so it is worse in a way. The order process is probably better structured than the one that is already implemented in the legacy system, but the old order process is still around. So we have a worse architecture, you could argue, because it became more complex. It will probably eventually become less complex once we might move more stuff over. But at the moment, we have more complexity, so you could argue it's worse. I'm not sure how important that goal really is, because we did not really get near it, that's for sure. But I'm not sure why this final architecture is so important for people. What matters is what you can actually achieve. And what matters is that we did provide some business features, and that we do have a perspective for things to become better. And I would like to tell you that, even if you have buildings, and if those buildings survive for long enough, you will end up with, I would argue, a similar architecture. So this is a building in Schleswig. That's a smallish town at the very north of Germany. And this building used to be a monastery. So it's, about 800 years old. It then became a home for the poor and now is part of the town hall. And why I really like this is because you can actually see how it changed over time, right? So there used to be a larger window here. Maybe there was another window over here. Not sure what happened over here. So this is sort of a legacy building in the sense that it has an architecture that is similar to a legacy system, but it's useful. It is part of the town hall, and people still use that building after 800 years. So if you have a building that is 800 years old, you end up with an architecture that is similar to a legacy system that is 10 or 20 years old, and both are still valuable. It's just that they are not aesthetically pleasing anymore, I would argue. Talking about that, one of the other metaphors that I like to use for these kinds of migrations is, let's imagine that we are taking a hike to the peak of some mountain. So that would be our project goal, or the metaphor for the project goal, a successful migration to a great all-modularized system. And ideally, you would expect there to be some kind of map that says, okay, this is the path that we are going to take to reach that project goal or to reach that peak of that mountain. And in my opinion, the real problem is, so how do we overcome the next obstacle that is on the way? So there might be a river. The trail might be closed for some reason. That is what happened to us. And those are the current requirements. Those are the requirements in the migration that come into our system. And then the question becomes, what is the next step? So in the metaphor, the question is, okay, how are we going to cross that river? What are we going to do about that closed path? And with the software system, the question becomes, okay, how are we going to implement the current requirements and still do something that is valuable for the migration? And I would argue, and that is why I like the metaphor, it's obviously stupid to say, I'm just looking down at the path and looking at the path and that's it. You need to say, okay, that's where we want to go. That is the peak where we want to go. But it's probably, so you shouldn't ignore that. But the focus has to be, okay, what's the next step? How are we going to cross that river? How are we going to overcome that obstacle? And that is also what I think we should be doing for migrations. It's more important to say, okay, what are we going to do in the next month, in the next year, than saying, okay, in 10 years, we are going to have that great, or 7 years, we are going to have that great new architecture. And in reality, too often I have the impression that people say, okay, there is the architecture, this is what the system should look like, and then some kind of magic happens, and magically that architecture appears, and that's in particular the case for migrations. While the real question should be, what kind of value are you going to generate in the next few months? And, you know, some parts of the system might just be beyond any repair and they might not be worth any investment, and you can isolate them and just let them be. That's the idea of big ball of mud. And there is again a paper about that pattern. And there is the pattern that is called sweeping it under the rug. So then you would just say, okay, we don't really care about that. It's just closed off. It's something that we never want to touch again. And that's a valid approach to handle, well, legacy systems. I did do a stream about that in German again, I'm afraid, but you can find the link to the original paper there and read that. One other remark that I want to make is, so that means that you will have that rather unpleasant architecture, and you need to make all those compromises that I tried to illustrate with that building in Schleswig. And maybe some migration cannot be motivated by business value anymore. So maybe at one point you're going to say, okay, well, this is really, really ugly. We really need to clean it up. There is no justification in terms of new features, but maybe you still want to do that, and that's fine. You just need to have a specific migration step that is just a pure migration step without any requirement that is implemented. The other thing that I just want to mention is migration is probably not the only option to improve. And the advantage that you have is you have an existing system and its environment. And there are usually lots of challenges and there are lots of options to improve the situation. So there's a lot of choice where you can do stuff that really advances your project. And one of the consulting gigs that I did was, well, we need to migrate to microservices to decouple teams. Well, that's a lot of effort, right? So you have a monolithic application. If you really want to decompose it into microservices, that's going to take a lot of time. So why are you thinking about that? Well, because it takes such a long time for stuff to be deployed. We have contention in the continuous delivery pipeline. So if a team tries to deploy something, it takes a long time until they have a spot for the next run of the continuous delivery pipeline where they can eventually take their code into production. So the alternative is to speed up the pipeline, and that's maybe a quick win, and that is what we did in that regard. And that's one of the cases where maybe an architecture optimization is not everything or the only option, but there are other options. So, conclusion. Legacy means we know a lot, and we can use that to our advantage. And you should provide business value during the migration. So we should let the domain drive the design. If you think this is valuable, here is a link to 60 Minutes Consulting that you can book with me. It's online. We will also provide a report. It's 99 euros. And here is the link. So you can just go there or take the QR code and book a slot with me or any of my colleagues. And also, if you enjoyed the presentation, you can send an email to this address. And then you will get a link to a OneDrive that includes the slides. I'm going to put them up there in a second. Samples from my books and also some free booklets. If you send that email, that's going to be handled by Amazon Lambda. And the data privacy is that your email address will be locked for 14 days on the Amazon infrastructure. That's the shortest time period I could set up. And if you misspelled the email address, I will handle it manually, so it will go to my inbox, but your email is not used, email address is not used for anything else. If you use the QR code, then that will take you directly to the OneDrive. So thanks a lot for listening. Thanks a lot for joining. I didn't see any questions in the chat or in the Q&A. So what do we do now, Mirko?
So, sorry, I need to, yeah. Okay, no, I don't see also any question. It seems to be you have answered already all questions, Eberhard. So, I would say, yeah, if there are no questions, then I say thank you to this really excellent talk, and thank you for being with us here, Eberhard. It was really absolutely interesting. Is there any question left? No, I can see it. No. Okay, then I would say
probably things were crystal clear.
Yeah. That's probably right. So then thank you for attending the session with Eberhard, and thanks a lot to you, Eberhard, for being with us.